All right, as we venture into chapter 10, we're going to look a little bit more at statistics and a little bit of probability. But before we get there, we need to determine how we can figure out how many outcomes exist in a given situation. So we're going to start that with learning about the fundamental counting principle. That principle states that if one event has m possible outcomes and a second independent event has n possible outcomes, calculating the possible outcomes for the two events combined is found by just multiplying the two together. So let's say you want to get a new case for your phone. Event number 1 on the case is picking this main shell. So if you read through here, you can choose any of 30 colors for the main shell. So that's going to be our event number 1. So there are 30 possible outcomes. However, we also get to select, so event 2, we also get to select the outer band's color. And we don't want to have a phone case that looks like everyone else's. You always kind of want to have maybe one that's a little more specifically you. So we want to know how many possible covers does this actually make so that we reduce the likelihood that we all have the same case in the end. So our second choice is 32 colors for that band. So we have 2 events. So if we have 30 options for event 1 and 32 options for event 2, the total possible phone cases that can be made, if these are the 2 decisions you're making, are found by just multiplying these 2 numbers together. So if we take 30 and we multiply it by 32, we'll get that there's 960 different color combinations that can be used to make a case for your phone. So that's how many choices you have. Probably cases. And that's the gist of the fundamental counting principle. So now let's apply it in some different situations. Let's say you set up an account and it asks you to enter a new password. The requirements of the password, and you're going to stick to just the smallest ones. So event A is that you have to pick 4 letters for your password. And event B is that you need to pick 2 digits, or event 1 and event 2, however you'd like to look at this. So this is event number 1. This is event number 2. Now sometimes to help remind myself what I'm trying to do, I'll make little hash marks to represent what I'm trying to find, so I make sure I don't forget one. So let's say these represent our 4 letters. So when picking a letter for a password, you have 26 choices since there's 26 letters in our alphabet. So when I pick the first letter, I have a choice of 26 letters. Now, this wording right here says that letters and digits can be repeated, meaning if I choose a letter for this first spot, I could use that letter again. So technically for the second spot, or the second letter I choose, I have 26 more outcomes. For the third, I still have 26. And for the fourth, I also have 26. So my 4 letters, if I multiply each of these together, and they're almost each their own event, they each have 26 outcomes possible for the 4 letters. Then, and it doesn't matter which order, because your digits could be intermixed, we also have to pick 2 digits. So if you count single digits, 0 to 9, you have 10 choices. Oopsie. So we have 10 we can choose from, and then another 10 the second time, since we can repeat. So our 4 letters and our 2 digits. So to calculate all the possible number of passwords that could be created, if that was the minimum requirement for your password, so let's go ahead and multiply these out. 26 times 26 times 26 times 26 times 10 times 10. We would get 4, 5, 6, 9, 7600. So there are 45,697,600 possible passwords. And this is why smart passwords exist, because it makes it harder to figure out your password because there's so many possible orders in which it could go. Now, how does this process change if we can't repeat something? So first you might think, is my number of possibilities going to get smaller or larger? And the answer would be smaller. Because if I can't repeat a letter, that means as I go through, and I'm just going to copy and paste, after I pick a letter, I have one less letter to pick from. So if we pick the same setup here, if I have 26 letters for the first choice, that means I only have 25 left for my second one, then 24 left for the third, and 23 left for the fourth. So if you ever see this cannot be repeated, it means as you calculate through your fundamental counting principle, the number of outcomes gets lessened by 1 for that particular item. So same with our digits. If I use a digit, so I have 10 for the first one, but once I use one, I can't repeat it, so now I only have 9 to pick from. So this should indeed give you a smaller number. It's still going to be quite large. But if we take 26 times 25 times 24 times 23, times 10 times 9, three, 2, 2, 9, 2, 0, 0, 0. So there's only 32 million options. Available to us. So that's why it's really important. Just check the wording, and you're going to have the opportunity to do both types, with repeating and without, because that'll affect how you calculate. So this is what we like to call the fundamental counting principle. We have several outcomes. We determine how many outcomes there are for each item. We multiply those outcomes together, and that gives us all the total number of possibilities. All right, so an extension of the fundamental counting principle is what we like to call a permutation. So a permutation of m number of objects is an arrangement when order matters. The number of permutations of n distinct objects is found by taking what we like to call n factorial, and it looks like a little exclamation mark. You don't say it like n, like it's an exclamation. It just means factorial, and I'll define that here in a second. So let's use our fundamental counting principle to set up number 3, and then we'll talk about how this factorial button can actually shorten the process down. So you have 8 skiers competing in a moguls competition. We want to know how many ways can those 8 skiers finish the competition. So first place. How many skiers could finish in first? Well, that would be 8. However, once one skier finishes the race, how many skiers remain to get second place? And then the answer is 7. So as we place our runners, 1st through 8, so 3rd, 4th, 5th, 6th, 7th, 8th, this is going to decrease by 1 times 6, 5, 4, 3, 2, and then our last skier. And that's how we could set this problem up. So we're literally going to take the number of skiers, which was 8, and we decrease it by one whole number all the way down to 1 to find out how many places all of these, or how many possible ways these 8 skiers could place 1st through 8th. So if we multiply this out, 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, we get that there are 40,320 ways that they could place. Now, if this number 8 gets bigger and bigger, that could be a lot to enter in the calculator. So that's why they created a button that assists you with finding this. So if I wanted a shortcut to entering this into my calculator, let me define our factorial here. I could just enter in 8 factorial. And again, if you wanted a way to know how that was written or mentioned, it's 8 factorial. So if you're reading this out loud or explaining it to someone else, that's how you read that notation. You don't say 8 really loud, exclaimed. You just say factorial for the exclamation point. So how do we actually use this on the calculator? So let me show you on the calculator I have here. Now, depending on which one you have, usually it's related to this PRB button. So mine's located here. Depending on the calculator you have, it might be in a slightly different place, but look for your PRB button. Now, we're going to use this NPR here in a second, but normally when you hit PRB, you're going to see these 3 options, and we're going to use these between these notes and the next set of notes. Factorial is right here. So before you hit it, you want to hit the number you need. So we need 8. Then I'm going to go to my PRB. I'm going to scroll over to my exclamation point and hit enter, and then hit enter again, and I get the same number. Meaning, what my calculator is doing for me is it's taking that number and is multiplying it by every whole number below it down to 1. So let me just give you some other examples in case that didn't quite sink in. So let's say you wanted to do 4 factorial. If you entered that in your calculator, what it's technically doing is 4 times 3 times 2 times 1. Or if I wanted to do 5 factorial, what it's doing is just taking 5 times 4 times 3 times 2 times 1. So anytime you use that factorial key, this is what the calculator is doing for you. Now, as a heads up, if you're using Desmos, which some of you might be using depending on your calculator options at home, you would just enter your number. So you'll see the 8 there in the top left. And then you're going to switch your keyboard over to just a normal keyboard. So at the bottom left, you'll see this ABC button. It switches you over to a normal keyboard, and you just select the exclamation point, and it should give you your answer. So you have a couple ways that you could use Desmos or your calculator to find the factorial button. All right. So we're still basing our things off this fundamental counting principle. We have a number of outcomes for each event. We multiply them together. However, if we have this specific pattern, we now have been introduced to a new button that we can use that makes that process go faster. Now, let's look at this same example, and let's say we're only concerned with who gets first, second, and third, which is typical for a race. So instead of just finding the permutations of all the objects, we're going to shorten it down, and I only want to focus on a certain number of places. When that is the case, when I don't want all of the objects, we denote it by this NPR button, which you might have just seen when I was looking for the factorial. When you use this NPR button on your calculator, what it's technically doing is it's taking all the possible outcomes. So however many that is, if it was the skier problem, that'd be 8 factorial. And it's dividing it by n minus r factorial, where r represents how many you want. So let's kind of put this into practice so you can see what's happening. So we're going to use the same example. We have 8 skiers competing in moguls, but now we're only concerned with the first 3 locations. So what in essence that we're doing, if we were to use the idea of the fundamental counting principle, we're saying I'm only concerned now with first, second, and third. So how many skiers could finish in first? That's 8. Then there's only 7 left for second and 6 left for third. So one way to find this answer would be to continue using that fundamental counting principle and just take 8 times 7 times 6, which is 336 orders. However, sometimes these numbers can get really large. So again, if we can shorten this process down, why not? So let's look at how this looks when we use the NPR button. So N represents the number of objects. So we are choosing from 8 skiers. R represents how many of them we'd like to choose. So we only want to choose 3 of the skiers to finish. So first, second, and third. So that's how many we're picking. Here's how you enter it in when you're using your calculator. So you're always going to enter the items you're choosing first. Then you're going to go onto the calculator and you're going to hit that NPR button. Then you're going to hit how many you're choosing out of those objects. On your screen, it probably will show up like this. And then it should tell you, hopefully, 336. So let me show you on my calculator. So first, let me clear this last one out. I'm going to hit the number of people we're choosing from, which is 8. Then I go to that PRB. I hit NPR. And then I tell it how many, actually I hit negative there, I'm choosing from. I want to know 3 places. And we get 336. So what it's doing is it's taking 8 factorial, oopsie. It's taking 8 factorial and it's dividing it by 5 factorial, because that's what 8 minus 3 is, to get that 8 times 7 times 6, which also gives you the 336. So 2 ways to accomplish the same thing. However, sometimes that NPR button is much quicker. Now, this formula is not as important for you to memorize. It's just so you know what the calculator is doing for you when you use that button. So let's practice that a few more times and then you're done with this lesson. So you have 6 text messages on your cell phone. How many orders can you reply to 4 of them? So order is important, meaning we're dealing with permutations, and that's also the case for part B. So in this possible case, we ask ourselves first, how many messages am I choosing from? So if we go to our original statement, we have 6 text messages to choose from that we need to respond to. So then we ask ourselves, how many are we trying to put in order? How many ways can I answer how many of them? So for the first one, we only want 4. For the second one, we want 6. So when these two numbers aren't the same, so you'll notice if you have a differing N and R, that's when you go to use that NPR button. So you would say 6, NPR 4. So if we go 6, NPR 4, there are 360 ways we could respond to 4 of the text messages. Now, to kind of bring it all together, if ever N and R are the same thing, that means you're technically rearranging all of them. So you could just do 6 factorial, or it would also work to do 6p6. So you have options. You could use the factorial button, you could use the NPR button, or you could even just get 6 times 5 times 4 times 3 times 2 times 1. So you could enter this in 3 possible different ways depending on what you want. These should all give you the same response. And that would be 720 ways to answer all 6 text messages. Now before I close these out, let me show you how to do the NPR button on Desmos. So let's go back to this one, the 6p4. We're going for 360 as our answer. So if we use Desmos, the NPR button, you'll see this functions over on the right. It pulls up this menu, and one of the items at the top is called stats, and you'll see NPR there. So if I hit NPR, I have to hit it first. Then I enter what N is. So if we were doing this text messages, that'd be 6 text messages. Then you put a comma to tell this Desmos N is 6, comma. Then you tell it what R is. So we wanted to know 4, and then it would tell us it's 360. So when you enter this in on Desmos, it is a little bit different, but Desmos is still a good option if that's all you have available to you.